All right, so 7.5 is on trapezoids and kites. So we kind of take a little detour away from parallelograms, which are rhombuses, and rectangles and squares are all parallelograms. These are not parallelograms. Okay, so a trapezoid has one pair of opposite sides parallel. So it could look, that's nice and crooked. Like that. It could kind of look like a parallelogram, just as long as that other side is kind of stretched out. Oop, not that one. That one and that one. Okay, and so we really don't know anything about just a regular old trapezoid. It's just one pair of opposite sides. Where we start to know stuff is if it is an isosceles trapezoid. So these two sides are congruent, and those two are parallel. Okay, so when it's an isosceles trapezoid, we know stuff. Okay, so we have base angles congruent. So just like in a isosceles triangle, an isosceles trapezoid, base angles are congruent. And we actually have two sets. So if we have that, makes it an isosceles trapezoid, the bottom angles and the top angles, just not the same number. So if the bottom numbers were both 60, then the top ones aren't 60. Kind of see that. Okay, and you can go back and forth with this one. So base angles are congruent if it's an isosceles trapezoid, and then if excuse me, it'll say if a trapezoid is isosceles, then base angles are congruent. And you can go the other way around. If base angles are congruent, then it's an isosceles trapezoid. Just like with the triangle, you can go back and forth. Okay, so when I put both directions, that's what I mean. If you know it's an isosceles, then the base angles are congruent. If you know that the base angles are congruent, then you know it's isosceles. Okay. The other thing that we know about an isosceles trapezoid is that diagonals are congruent, so just like a rectangle. Okay, so there's three theorems there, but two of them are just the base angle. One is if it's isosceles, and it's base angles. If the other one's the base angles, then isosceles. Okay. All right. Sorry about. Then we also have, for a trapezoid, what's called the midsegment theorem. And so what that says is the midsegment equals half of, and I'm going to just write base plus base. So the theorem says the midsegment of trapezoid is parallel to each base, and the length is 1/2 the sum of the bases. Okay, so it doesn't have to be isosceles. And so the midsegment would go right through the middle. And so it would have to tell you that all three are parallel. Okay, so if they're not all parallel, then this doesn't work. Okay, so it simply says, like, well, if that's 12 and that's 28, find EF. Well, you're just going to do 12 plus 28 equals 40, and then you're going to do half of 40 is 20. Okay, so here's something else I want to point out. This is kind of a shortcut. So you could do the formula, add the bases together, divide by 2. Okay, but here's something else I want to show you that I think is helpful. So from 28 to 20 is a difference of 8. And from 12 to 20 is a difference of 8. That will always happen. Okay, so it's all, you could ask yourself, mid-segment, what's in the middle? What number is in the middle of 12 and 28? And that can be helpful, okay? Because you could see, or you will see, let's see a problem like this. Let's say it tells you they're all parallel. And so what if this one was 12 and that one was 15 and it wanted to know that one? Well, from 12 to 15 is a difference of 3. So there has to be a difference of 3 here. 15 and 3, 18. Okay, it always has to have that relationship. Okay, so you'll have some different questions on with trapezoids that involve mid-segment and then some of the angles. You know, the two sets of base angles are congruent. Okay. All right. So then let's look at kite. So a kite has, let's see the exact verbiage, it has two sets of parallel sides. I think it says adjacent. Consecutive, okay. So two sets of consecutive sides congruent. So the standard kind of picture of a kite is like that, and so we'd have those congruent and those congruent. Okay. All right, so we know two things about a kite other than the sides being congruent. That's what defines a kite. So we have diagonals are perpendicular. Okay, and then we have one pair of opposite angles congruent. Okay, and so I will, and it's always where the two non-congruent sides meet. So, which pair are congruent? Well, it's the two that, where the two non-congruent sides meet. Okay, so if you had a problem like this, and it said angle A equals 105 degrees, angle C equals 35 degrees, what's angle B? Okay, well, first you would need to remember that this has 4 angles, so the total is 360. You can do the number of sides minus 2 times 180. Talked about that at the very beginning of the chapter, but 3 sides being 3 angles in a triangle, 180. 4 angles being 360. Those are the two that really should be memorized. Okay, so these two add up to 140. So I have 220 left. But if both of them are congruent, then they have to be the same. So then I would do 220 divided by 2 is 110 degrees. So angle B and angle D would be 110 degrees. Okay, so that kind of problem will come up a couple times in different formats where you know that 2 angles are congruent. So just, if you know what they add up to together, then you're going to have just divide by 2. Okay. All right, so just a few problems, not a lot, on excuse me, trapezoids and kites. Okay. All right, that's the last section of chapter 7. We'll do some review next week. All right, have a great Friday, good weekend, and we'll see you on Monday.